In this video, we are given with the identity, the limit of e to the power of z minus 1 over z as z approaches to 0, which is equal to 1. This is the identity that we have been using for some of the examples previously, and of course, similar to the identity in the calculus concept in containing real numbers. This is also true. Instead of z, we are using x. But we are going to show that this is true using the L'Hopital's rule. Yes, the L'Hopital's rule is also one of the proof, or can be used as a proof to determine that this is really true. Now, in one of the videos in our calculus playlist, we're able to guarantee that this is true. Again, instead of z, we're using x. But that is actually using values of x as it approaches to 0. But since we are now on complex numbers, let's not use that. Let's use the L'Hopital's rule to prove this further. So that would mean we're going to show here the proof. Let's start with the left-hand side, e to the power of z minus 1 over z as z approaches to 0, and hopefully yield to our right-hand side, which is just equal to 1. According to L'Hopital's rule, this is only true when we substitute 0. This would be indeterminate form. Of course, if we're going to do that, e to the power of 0 minus 1 over 0, you have your 1 minus 1 over 0, 0 over 0, indeterminate, right? So since it's indeterminate form, let's use here the L'Hopital's rule using f of z as our numerator, e to the power of z minus 1, and our denominator as g of z, which is just equal to z. Now, let's take the first derivative of f of z. The derivative of e to the power of z is itself e to the power of z, and minus 1 is minus 0, which would give us a derivative which is equal to e to the power of z. This is the first derivative of f of z. As for our denominator, its first derivative is just obviously equal to 1. Okay? So that's equal to 1. Now, this is not equal to 0, and according to the L'Hopital's rule, we can now use the ratio of the derivatives, giving us this next notation, the limit of our original form, e to the power of z minus 1 over z as z approaches 0, according to L'Hopital's rule, is just equal to the limit of the ratio of the corresponding derivatives. You have e to the power of z over 1 as z approaches to 0. Substituting the z, you will have e to the power of 0 over 1. This is actually 1 over 1 equal to 1. This, let's not declare it there, but let's cut all this middle portion. Hence, we have shown that the limit of e to the power of z minus 1 over z as z approaching to 0 is equal to 1 using the L'Hopital's rule. This was the given identity earlier. So this is additional proof. Again, the proof for calculus where we use x instead of z, but now for the complex numbers, it's now further proven to be true for complex numbers and this identity. And of course, as we look into that later on, we can now use that in future examples as well. Thank you very much for watching.